Good evening, students. Today we are going to discuss the new topic of linear differential equation. There are two types of linear differential equation, that is linear equation of constant coefficients and the homogeneous equations with the variable coefficients. Today we will discuss only the differential equations which have constant coefficients. Constant coefficients, first of all we will define it. Let's suppose there is a differential equation like this one in the form of dn of y xn and a1 a2, where a1 a2 an are the constants. That is why we call it as a linear differential equations with constant coefficients, and qx is the function of x. If we call it write as d by dx as d and set in derivative as d square and nth derivative so on, nth derivative will be dn, then the equation will become as dny plus a1 dn minus 1 of y and so on, an of y is equals to qx. Or we can say it is a function of d of y having the coefficient of constants is the qx. Now we will discuss how to solve it. For solving this type of the linear differential equation, we have to find two types of solution. First of all, complementary functions. In that case, this qx will become 0. When qx will become 0, we can say it is a constant coefficient equation. We have to find the complementary function. If there is a function of qx there, then we will find complementary function as well as particular integral. Let us discuss about this. So here we go further ahead. For the solution of f dy of qx, in case when qx equals to 0, the equation will become like this one. Then the step number 1 is obtain auxiliary equation by replacing d as m in fd. We get the equation can be written as with an m to the power n plus a1 m n minus 1 plus a2 m n minus 2 and so on, plus an is equals to 0. Let's suppose, because it is an polynomial equation, so we can say it have nth root also. So we can say let the n roots of the equation are m1 m2 and so on mn. Now there are few steps we have to remember. That case number 1, if all roots are real and distinct, then the complementary function, the solution, you can say the solution is y is equals to c1 e to the power m1x plus c2 e to the power m2x plus and so on plus cn e to the power mnx. This is our solution if the all roots are real and distinct. Now ahead for that, if there are some other cases also. Case number 2, if we can say if m1 is equals to m2, say m, then the solution is y is equals to e to the power mx, you can say c1 plus c2x e to the power mx plus c3 e to the power m3x and so on. Means when there are two equal roots, then we can write as c1 plus c2x, and the equal root will become only one time. Case number 3, if m1 is equals to m2 is equals to m3, say m, now there are three equal roots, then y will equals to c1 plus c2x plus c3x square of e to the power mx plus c4 e to the power m4x and so on. There are some special cases also. Means there is no necessity that always a simple roots are there. There can be also the complex roots. So case number 4, if m1 is equals to a plus iota b and m2 is equals to a minus iota b, so we can say about complex roots. Then what about y? Then y is equals to e to the power ax c1 cos bx plus c2 sin bx plus c3 e to the power m3x and so on. If there are only one complex root is there. Case number 5 also there. If roots are equal and imaginary, I mean to say the roots are a plus minus iota b, again there are another root a plus minus iota b, then what will happen? Then we have to combine the two rules, case number 4 and case number 2 also. We will combine both the methods. Then I will get y is equals to e to the power ax, then c1 plus c2x cos bx plus c3 plus c4x sin bx. There is another case, last case we can say, it is a rare one when permitted. Now let the roots are real, different and surds. If roots are real, different and in the surds, what do you mean by surds? Means a plus root b and a minus root b. Now it is not no iota, there is no imaginary root, but in the root, square root form, then the solution will be y is equals to e to the power ax c1 e to the power root bx plus c2 e to the power root minus root bx. This is a special case. You should learn it about this. These 6 type of cases we have to remember for solving the linear differential equations with constant coefficient for solving them. Now let us do some examples so that we can understand it very carefully now. So now is the first example. Solve the differential equation. Here we can say let d by dx is equals to d and d square by dx is equals to d square and so on. Then equation become d cube plus 2d square minus 15d of y is equals to 0. Now for the auxiliary equation, put d is equals to m so that equation become m cube plus 2m square minus 15m is equals to 0, or I can say m is common, that is m square plus 2m minus 15 is equals to 0. You know how to factorize it. So the factor will be, what will be the factor? That is m plus 1 m minus 3 will equals to 0. So we can say m is equals to 0, m is equals to minus 5 and m is equals to 3. As we get all the solution, we can see here the roots are real and distinct. So the first case, y will equals to c1 e to the power 0x plus c2 e to the power minus 5x plus c3 e to the power 3x, or we know that as e to the power 0 is always equals to 1, so we can say y will equals to c1 plus c2 e to the power minus 5x plus c3 e to the power 3x. This is the required solution of the given differential equation. Now another question I have written already in short form, d square plus d plus 1 of y is equals to 0. So we can say the solution, the auxiliary equation by putting d is equals to m, we get m square plus m plus 1 is equals to 0. As we know, it is a quadratic equation, so we can use the Sridharacharya rule, or you can say quadratic formula. By the quadratic formula we can say m will equals to minus b plus minus under root b square minus 4ac upon 2a. If you don't remember that, then I write here. So we'll put m is equals to minus b, means minus 1 plus minus 1 minus 4 upon 2a, 2 into a and 1, that is m is equals to minus 1 plus minus, this will be minus 3, which is an imaginary part, so we can say it is iota root 3 upon 2. So we have the two roots, that is minus 1 by 2 plus iota root 3 by 2 and minus 1 by 2 minus iota root 3 by 2. As you can see here, the both roots are complex, so we can say the roots are complex. Then the solution is c1 e to the power ax, means a plus minus iota b form. So it is e to the power ax plus into c1 cross bx plus C2 sine bx. What is a and b here? We can see the real part of the complex root is the a as in the form, and the imaginary part is as b. Put the values, we will get y is equals to e to the power minus 1 by 2 c1 cos root 3 by 2h plus c2 sine root 3 by 2h is the required solution of the given differential equation. Here is another question. Solve the equation d to the power 4 minus a to the power 4 of y is equals to 0. This equation can be written as this one also. So now the auxiliary equation is, by putting d is equals to m, I can say m to the power 4 minus a to the power 4 is equals to 0. Factorizing m square minus a square, m square plus a square is equals to 0, or we can say m square is equals to a square and m square is equals to minus a square. From here I will get m is equals to plus minus a, and here m is equals to plus minus iota a. So there are four roots, that is a, minus a and the plus minus iota a. As you can see here, the first two roots are real and different, but the third root is a complex pair root. So we can say the solution y is equals to c1 e to the power ax plus c2 e to the power minus ax for the real and different roots, plus e to the power 0x, it is nothing, just 0 plus minus iota a, so it is 0x, c3 cos ax plus c4 sine ax. As we know that e to the power 0 is equals to 1, so y will equals to c1 e to the power ax plus c2 e to the power minus ax plus c3 cos of ax plus c4 sine of ax. This is the required solution of the given differential equation. So you understand how to solve. There are three questions I have given. Solve them and try it also. In the next lecture we will discuss about the general solution of the equation of f dy is equals to qx, where qx is the function of x. We know that. In the next class we will discuss it. Till then, practice these questions. These are the important questions for the exam point of views.